Hello, I am Dr. Shilpa. Today I am going to explain the spread spectrum communication. These are the contents. So, what is spread spectrum communication? How it works? What are the application and what are the different techniques we have in this spread spectrum communication and applications and then conclusion. Next, introduction to spread spectrum communication. So, spread spectrum radio communication. It is a favorite technology of the military because it resists the jamming and is hard for any enemy to interrupt, just as they are unlikely to be interrupted by a military opponent. This is the general model of a spread spectrum digital communication system. In this mainly we have three parts. One is transmitter, channel and then receiver. So first we will explain about the transmitter. So in this transmitter, first the binary information sequence is input to the channel encoder on transmitter side. And also this channel encoder, it will encode this input sequence according to some error control coding techniques. And also the coded sequence, it is then given to the modulator. Here the modulator gets a pseudo-random sequence from the pseudo-random pattern generator. So which we can see in this block diagram here. This pseudo-noise sequence spreads the signal randomly over the wide range of a frequency band. And also the signal at the output of the modulator is the spread spectrum modulated signal. And also this signal is then transmitted over the some channel. Next, we have a receiver. So in this receiver, at the receiver end, the demodulator will get the coded signal back from the spread spectrum signal. For this purpose, the demodulator requires the same pseudo-random sequence which was used at the transmitting end. Hence, the pseudo-random pattern generates at the transmitter and receiver side operate in synchronization with each other. Next, the channel decoder at the receiver then gets the binary information sequence back. Thus, the receiver can detect the transmitter spread spectrum signal only if it knows the pseudo-random sequence. So, for any arbitrary receiver, it is difficult to know the pseudo-random sequence since it appears like a noise. So, this is the general model of a spread spectrum digital communication system. Next, this is the overview of a spread spectrum communication. That means that here spread spectrum means it is a means of transmission in which the data sequence occupies a bandwidth in excess of the minimum bandwidth necessary to send it. So that is effectively the signal is mapped to a higher dimension signal space. Next, this and also this signal spreading is done before transmission by using a spreading sequence. Then the same sequence is used at the receiver to retrieval the signal. Next, this spread spectrum is most effective against interference with fixed energy. The main commercial application in wireless and GPS system. So why we have to use this spread spectrum? So why in the sense here this spread signals are distributed over a wide range of frequencies and then collected back at the receiver. And also these wide band signals are noise-like and hence difficult to detect or interfere with the other signals. Initially adopted in it is this spectrum. This spread spectrum technique is adopted in military applications for its resistance to jamming and difficulty of interception. More recently adopted in commercial wireless communications. Next, why we need this spread spectrum? So mainly we use this spread spectrum for the security purposes. That is, a safeguard for physical security must be even greater in wireless communication. And encryption in the sense intercepted communication must not be easily interrupted. And also for authentication, that is authentication is the node who it claims to be. Next, how this spread spectrum works. The spread spectrum uses a wide band noise-like signals because the spread spectrum signals are noise-like. They are hard to detect, and also the spread spectrum signals are also hard to intercept or demodulate. Further, spread spectrum signals are harder to jam or interference with the narrow band signals, and also these low probability of intercept and anti-jam features are why the military has used spread spectrum for so many years. Next, we have spreading codes. Spreading codes in the sense it is a noise like and random signal has to be generated at the transmitter, and also the same signal must be generated at the receiver in a synchronization, and we limit the complexity by specifying only one bit per sample, that is a binary sequence. And also this spectrum signals use fast codes that run many times the information bandwidth or data rate. And also these special spectrum codes are called pseudo random or pseudo noise codes, and these are also called pseudo because they are not real Gaussian noise. So PN sequence. So here this PN sequence or PN generator produces a periodic sequence that appears to be random. PN sequence is generated by an algorithm using initial C, and also this sequence isn't statistically random but will pass many tests of randomness. And also these sequences are referred to as pseudo-random numbers or pseudo-noise sequences. And unless the algorithm and seed are known, the sequence is impractical to predict. Next, important of properties of this pseudo-random sequence. So the main properties of this pseudo-random sequence are uniform distribution, balance property, run property, and independence and correlation property. And next we have unpredictability. Here balance property means first, in each period of a sequence, the number of ones is always 1 more than the number of zeros. So, for example, if we consider a 3-stage shift register, then n will be equals to 2 to the power of 3 minus 1. Then we will get the n value will be equals to 7. Next, we have a run property. So, run property in the sense here, a run is defined as a subsequence of identical symbols within the sequences. The length of the sequences is known as the run length. That is, the total number of runs will be equals to n plus 1 divided by 2. Next we have autocorrelation property. Here in this autocorrelation property, the autocorrelation function of an sequence is a periodic and a binary value. That is, it will be equals to 1 divided by n, summation of n equals 1 to n cn into n cn minus k. Next, this SPECT spectrum techniques. So the major SPECT spectrum techniques are DSS and FHSS. DSS in the sense a direct sequence spectrum, and FHSS means a frequency hopping SPECT spectrum. So next we have direct sequence SPECT spectrum. So this direct sequence SPECT spectrum in the sense it means that it does not use any digital modulation technique, and also this digital signals bandwidth is widened by using only the spreading codes or by using the PN sequence. And also the baseband signal which is of a low bandwidth or narrow bandwidth, it will be multiplied with the wideband signal C of t to obtain this specific signal M of t. Then the spectrum signal M of t is transmitted to the channel where additive noise will be added in the signal. Next, the received signal at the receiver end, the received signal will be consisting of a transmitted signal M of t as well as the additive noise signal. Next, that received signal will be passed to the demodulator, where the demodulator will consist of a multiplier and a low pass filter, where low pass filter is used to reduce the additive noise in the signal. Next, at the output, so we will get the message signal back. So this is how the direct sequence spectrum will work. Next, we have a processing gain. Processing gain in the sense this is a performance of a direct sequence. Here, processing gain is defined as the ratio of the bandwidth of a spreaded message signal to the bandwidth of the unspreaded data signal. It is given by bandwidth of the spreaded signal to the ratio of the bandwidth of the unspreaded signal. This is an example of a DSS. So this is spreaded code, this is a spreaded information and a data. Next, we have frequency hopping spread spectrum. So this is another type of an spread spectrum technique. So here a digital signal is modulated with a narrow band signal that hops from frequency band to the frequency band over time, and also the transmission frequencies are determined by a spreading or hopping a code or pseudo random sequence. So, and also in this frequency hopping spectrum classification, we have two types, that is slow frequency hopping spectrum as well as a fast frequency hopping spectrum. Slow frequency hopping spectrum in the sense here the several symbols of data are transmitted in one frequency hop. Then it is called as a slow frequency hopping, and also this means that the symbol rate is higher than the hop rate. That is hop rate is slower than the symbol rate, hence it is called as a slow frequency hopping. Next we have a fast frequency hopping. So here several frequency hops takes place to transmit one symbol. Then it is called as a fast frequency hopping. Here several hops will be equal to one symbol transmitted. Here, this is the frequency of this spectrum. Here, this is a channel assignment and this is the channel usage. Next, here, this is the carrier frequency is hopping according to the unique sequence. Next, we have applications. So, what are the applications where we can use this spread spectrum techniques? So first I'll consider the first one, motivation has radio channel availability. So here in radio jamming is a very present threat to radio channels. So this is an attack on the availability of signals. So traditional anti-jamming techniques on a pre-shared secret codes to increase the channel availability. So in this application we were using the spread spectrum technique here. Next, we have anti-jamming communication. So here the spread spectrum techniques, in this we are having a frequency hopping spread spectrum and direct sequence spread spectrum. So hopping sequence and spreading code. So here we have shown the hopping sequence as well as the spreading code. Next is Bluetooth. So here this Bluetooth phone and headset and we have a printer module here. So the universal framework to integrate a diverse set of devices in a seamless, user-friendly, efficient manner, and also devices may be able to establish ad hoc connections and also support for data and voice and also similar security as cables, simple, small power, efficient implementation, and also it is inexpensive. Next we have co-division multiple access. So here multiple transmitters in the sense it will have multiple transmitters and one receiver, and also choice of unique sequence to spread the data bits, and also ability of a receiver to distinguish between the data streams. Next, advantages. So the different advantages of using these spectrums are it will reduce crosstalk interference, better voice quality, and lower the susceptibility to multipath fading and inherent security, coexistence, and we can transmit for a longer distances and hard to detect, and also it is hard to interrupt or demodulate and harder to jam the signal. So these are some of the advantages of using spread spectrum techniques. So conclusion. Here the spread spectrum it promises several benefits such as higher capacity and ability to resist multipath propagation. And also spread spectral signals are difficult to interrupt for an unauthorized person, and also they are easily hidden. For an unauthorized person it is difficult to even detect their presence in many cases. They are resistant to jamming, and also they provide a measure of immunity to destroy due to multipath propagation. They have multiple access compatibility, and also this spread spectrum is now finding a widespread civilian and commercial applications such as cellular telephones, personal communications, and position location. For example, DSS is used in Electronic Industries Association's intern standard IS-95 for cellular telephones, as well as a wide range of position location systems such as the GPS system and other vehicle location and messaging systems. Thank you.